Hello and welcome. In this video we will explore how you can enhance your test preparation with the diagnostic simulation. I'm Thomas Blocher, an application engineer and trainer at Softing Automotive. The need for automotive testing throughout the vehicle's life cycle is increasing because of the growing complexity of electrical and electronic systems in modern cars. However, conducting testing and validation is expensive due to the costs for prototypes, the devices under test, and personnel. Product development cycles must be shortened to accelerate the time to market for new models. With reduced time for testing, future automotive development projects will require more testing and validation work to be completed within tighter schedules. This challenge can be addressed through virtual product development techniques and simulation. Testing covers a spectrum of areas spanning from component and system testing to comprehensive vehicle testing. To enable these tests, the necessary hardware components must be available, such as control units, hardware-in-the-loop systems, or test vehicles. However, these devices under tests are not or only partially available at the beginning of the development process. To overcome this problem, one approach is to utilize simulation techniques and virtual prototyping early in the development process. By creating virtual representations of the components, systems and vehicles, engineers can conduct testing and validation in a simulated environment before physical prototypes are available. This allows for early identification of potential issues and optimization of test designs without the need for physical components. The test procedures for control unit, mechatronic system, or vehicle testing need to be created and approved. An error in the test procedure or the communication chain from automation system, diagnostic system to vehicle communication interface can only be detected once the device under test is available. Additional effort is required for analysis and corrective actions. This results in a significant additional workload, and the test can only be carried out with delay. To overcome this problem, the test system is validated using a simulated vehicle system or single control unit. The simulation is created preferable based on the ODX specification. Once the device under test arrives, the test can be conducted. Errors can be clearly attributed to the device under test, eliminating the need for rework in the test system. The diagnostic specification is the only source for implementing the simulation, which is usually available today as ODX data. In test preparation, creating simulations based on ODX data has proven to be an efficient approach. ODX is the diagnostic specification, which makes it easy to assemble appropriate pairs of requests and responses based on service parameter values. This helps to avoid input errors. For the creation of a diagnostic simulation, we need 3 ODX key elements. ODX-V outlines the vehicle-specific information, such as the topology and the pin assignment of the diagnostic interface. ODX-C and CS specifies the bus communication protocol like CAN or diagnostics over IP, along with their corresponding parameters such as baud rate or CAN ID. ODX-D is the heart of the ODX data, describing the control of the diagnostic services for a specific electronic control unit. It is named Diag Layer Container. In ODX, a diagnostic service refers to a standardized procedure or operation performed by a vehicle's electronic control unit in response to a diagnostic request from a diagnostic tool. These services are essential for conducting diagnostic operations, such as reading sensor data, retrieving diagnostic trouble codes, executing self-tests, and configuring ECU parameters. The simulation for the diagnostic services can be automatically generated from the ECU's ODX diag layer container. Matching pairs of diagnostic requests and responses can easily be compiled using service parameter values. Softing TCS consists of various components and functions. TCS admin is used to create and configure and administrate diagnostic simulation files. The simulation files contain ECU definitions for the base and ECU variants, communication parameters, and diagnostic services. TCS device is the hardware for the diagnostic simulation of vehicles or ECUs, supporting CAN or CAN-FD and Ethernet buses. It is compatible with different diagnostic protocols such as UDS, KWP 2000, OBD, and J1939. Instead of controlling the TCS device through TCS admin, it is possible to manage the device from a user-specific application using the TCS test bench library in the test automation scenarios. The application TCS Operate allows for the control of the TCS device hardware based on the TCS test bench library. In the following demo, I'm going to show you how you can create an ODX-based project and generate a diagnostic simulation automatically with Softing TCS admin. Also, you will see how to manually adapt parameters in a generated simulation. Let's explore how we can generate a diagnostic simulation for a variant of the engine control module ECM using ODX data. The first step is to determine which ODX data will be used to create the simulation file. In TCS admin start page, we select the task Create ODX project for this purpose. In the project wizard, we choose Create New Project from ODX or PDX files. This allows us to select different ODX files or a complete archive of different ODX files in packed ODX format for our simulation project. I am going to add different ODX files for the simulation of the engine control module. We need to add ODXD files for the diagnostic services of the control module, ODXV, which defines the topology, and for the bus communication parameters we add the ODXCS and C files. Now we define the project name and the database output format SOD, which is an editable ODX runtime format. Finally, we generate the project. Now we can choose the task Create Simulation from ODX. This will allow us to create the simulation based on the saved project. In this dialog, we select the location from the ODX data, which is the engine control unit's variant ECM 001. The simulation file is generated now and opens in TCS admin. The left side displays the ECU's name and description for the engine control module's base variant and its variant ECM 001. On the right side, we can find the communication parameters for the bus system and the ECU's diagnostic services based on the Unified Diagnostic Services, short UDS, protocol. Let's see how we can change a diagnostic response within TCS admin. Therefore, we choose the diagnostic service for reading the vehicle speed and select in the context menu Edit Service by ODX. The service parameters can now be changed symbolically, which means we do not need to work on the PDU hex level. I'm going to change the vehicle speed to 10 km per hour by double-clicking into the value field. We can also add further responses with different values for the vehicle speed to simulate an acceleration of the car. This view shows us two responses we have modified for the diagnostic service: read data by identifier, vehicle speed. In the following, the simulation can be saved and downloaded to TCS device and used for your diagnostic testing for the engine control module. Let's summarize what we have seen so far. The missing ECUs for the test creation and verification can be overcome by a diagnostic simulation. It is time-saving by making all devices under test available via simulation, provides significant cost advantage through early detecting of errors and the avoidance of rework, and it simplifies the creation of a simulation by automatic generation. My name is Thomas Blocher. Please feel free to contact me if you have any questions.